The first homes in Longyearbyen were built in 1906, and a coal mining community was established. As mining operations shifted between different sites, buildings were relocated. Little consideration was given to risks from flooding, avalanches, and landslides. Over the years, climate change and extreme weather events have made it increasingly important to consider natural hazards, both to protecting existing buildings and to plan for new ones. The avalanches of 2015 and 2017 particularly highlighted Longyearbyen's vulnerability. On the 19th of December 2015, a major avalanche struck parts of Longyearbyen in Svalbard. Triggered by a severe storm and heavy snowfall, the avalanche cascaded down the mountainside above the Lea residential area. An estimated 5,000 tons of snow tumbled down Mount Sukatoppen that morning. The avalanche hit 11 houses. 2 people lost their lives, several others were injured. Around 100 people were evacuated from the area. Rescue operations were carried out by local residents, emergency services, and volunteers. On the 21st of February 2017, the Lea residential area was hit once again by an avalanche. 2 homes were struck. Fortunately, no lives were lost, but the event caused significant damage to property. The avalanches of 2015 and 2017 demonstrated the urgent need for permanent safety measures in Longyearbyen. In cooperation with the Longyearbyen Local Council and the Governor of Svalbard, NVE started extensive works to protect the town from future avalanches and landslides. A total of 2,000 meters of steel snow bridges have been erected to prevent the release of dangerous snow avalanches. The bridges are secured deeply into the permafrost to maximize stability. Snowdrift fences have also been installed to reduce the accumulation of snow above the town. A 400-meter-long retaining wall, up to 6 meters high, now protects buildings from both snow and landslides. The wall also diverts surface water safely. In a nearby valley, 14 debris flow nets have been installed to slow down slush flow, an increasing threat due to warmer winters and more rainfall. These nets are designed to hold back debris while allowing water to pass through. They are anchored with 1,000 steel bolts drilled up to 9.5 meters into the permafrost. The River Longyear transports large amounts of rock, gravel and sand, which can lead to erosion, flooding and damage to nearby buildings and infrastructure. To mitigate this, a sedimentation basin has been constructed to capture the bedload. Additionally, several weirs have been built to reduce water velocity, and riverbanks have been reinforced to safeguard nearby buildings and roads. Longyearbyen now features some of Norway's most advanced avalanche and landslide protection measures, designed to last at least 50 years. Avalanche and landslide risk is continuously monitored using temperature sensors embedded in the permafrost. Data analysis builds knowledge of how the hazards are affected by climate change. Residential buildings in high-risk areas are being relocated or demolished, and plans for new developments take the risks from avalanches, landslides, and flooding into account. These implemented measures mean that Longyearbyen is now in a better position than ever before to face the challenges of living in an Arctic environment, offering improved safety for both residents and visitors.